Hi Ecology Lab. I just want to go over some examples of how to run some of the code for lab number 2. The goal of lab number 2 is really just to get you a little more familiar with working with data in R. In lab 1 we loaded some data in and we made a basic graph and things like that. So we're going to build on that a little bit, and we're going to make a couple different kinds of graphs as we explore sort of community level data. So data collected with multiple species in the same place. Okay, so let's get to it. Number 1, I have a folder here with the data that I need. You can download all those from World Class, put them in a folder somewhere. And so the main things you're going to need, I have my script written here. That's in the lab assignment as well. All the code here is there for you to run. You can copy and paste it into your editor window or do whatever you want with it. But you're going to need leaflitterinverts.txt, nhlepid.txt, and tnmoths.txt. So those are all tab delimited text files of some different ecological data that we're going to use. Don't forget, before you start, when you have those in a folder somewhere, don't forget to set that as working directory. So you just go under More and go Set as working directory. You see in my console window it sets this folder as my working directory. That folder can be anywhere on your computer, or if you're using one of the virtual desktops, you can set it there, or you can even use like OneDrive, some kind of cloud-based folder, which is probably a good idea because then the data and all your stuff follows with you. Anyway, so okay, for the first example, let's load in the data. So we're going to do leaf litter inverts. Right, so just like last week, this is a tab delimited text file. We're going to use that read.delim function. So I'm creating a variable here called inverts, and then this assignment operator, the less than and hyphen, and we're going to read into that variable this file, so read.delim, and then here's the file name right here. So I'm going to hit Alt-Enter to run that file. There it is. And then in my console window, if I just type inverts, it shows the data, right? So I have different taxa here of leaf litter organisms, and then in plot number 1, the total number of each of those, and in plot number 2, the same thing. So Acari is mites, and so in plot 1 I have 50 mites, in plot 2 I have 10. Annelida is segmented worms. I have 1 in plot number 1 and 0 in plot number 2. Okay, so very simple, and we've got just a little bit of data there. Now, in the lab, it asks you in a couple of these different examples to calculate the species richness. Now, remember, species richness is just the total number of each species, or in this case, taxa, because these are orders. The total number of taxa present in the sample, right? So in the plot or whatever. And so one way to do that is we can use this line of code. So I'm creating a variable called richness.1 for plot 1, that assignment operator, and then if you use this sum inverts, so that's my data frame there, inverts. The $sign means choose this column. So the column is plot 1, and so I'm going to look at that column. So I'm basically counting the entries in that column that do not equal 0. So the exclamation point equal sign means not equal to 0. So if I run that, we create a new variable called richness. If I type richness 1, see my answer is 8. And that's easy to see here because there's only 8 rows. There's data in all of them. In plot 2 we can see there's 2 zeros, so there's 6 is the species richness or the taxon richness. But if you have a data set with like hundreds and hundreds of rows or thousands of rows, it can be really hard to count up those zeros and you can make mistakes. So you can use this code to do that kind of thing. So I'll run it for plot 2. Now we're going to make a rank abundance graph. So a rank abundance graph is basically a line graph that plots the data from the most abundant species down to the least abundant, and so the shape of that curve tells you something about the diversity of the species in the plot. So I'm going to create some new columns in my data frame here. So I'm going to go proportion 1 and proportion 2 are the two columns I'm gonna create. And so again, I'm going to start with inverts. That's my data frame. The $sign means a column, and then proportion 1, that's going to be a new column. And And into that, with the assignment operator, I'm going to basically just calculate the proportion. So of each taxon, what's the proportion of that taxon contributes to the whole, right? So I have inverts plot 1 divided by the sum of that whole column, inverts plot 1. Okay, so that's the ratio. So for instance, Akari, mites, it's 50 divided by the total, the sum of the whole column, right? And I'm going to do the same thing for plot 2. So Alt-Enter for plot 1, Alt-Enter for plot 2. Now down here in my console window, if I type inverts, you see we've added 2 new columns here. So the proportion for plot 1 and the proportion for plot 2. So for instance, Akari, 50 out of the total here, that's 40.43. These 2 columns will sum to 1, right? Okay, now to make our rank abundance graph, we have to sort the data from most abundant to least abundant. So I'm going to do that here. I'm going to create a new data frame called inverts.1 for plot 1. And I'm basically going to sort that inverts data frame. And so I'm going to use this order function. So order, open bracket. I'm going to use a negative sign here because I'm going to sort from highest to lowest. And then inverts $ proportion 1. So I'm sorting that proportion 1 column from high to low. So here we go, Alt-Enter. That's done. We're going to make another one. Sorting high to low for plot 2, so the same thing except I'm going to use plot 2. Okay, so that's done. Now we can make our rank abundance plot, right? So I'm going to plot first that inverts 1, so plot 1. Type O equal, that means basically the type of graph you're going to make. So it's going to be a line graph, but this is going to be an overwrite because I'm going to add different lines to it, so that's why it's O. The X limit, this means my X-axis is going to go from 1 to 7, and my Y limit, because I've got 8 species here, and my Y limit is going to go from 0 to 1. Okay, so the color of the line is going to be red. PCH means point character, and so I'm going to choose just option 1, which I think is an open circle. CEX is the size of those points. X label is, I'm going to label the x-axis as rank. I'm going to label the y-axis as proportion of abundance. And the main title is going to be rank abundance plot of leaf litter invertebrates. Okay, let's run it and see if it works. And there we go. So over here in my plot window, I've got, oh, and you see, I messed up because there's 7 here, but there's 8 species. So I'm going to go back and redo that plot. I'm going to change this xlim 1 to 8. And let's run it again. There we go. Okay, so I've got all 8 species on the graph here. We can see it's a red line with open circles for points. Okay, now I want to add my blue one. I want to add the second. I want to add plot 2. And so I'm going to do that here. I'm going to use the lines function, open bracket, inverts 2, proportion 2 column. The same type, type O. Line width is going to be 2. Color, I'm going to make this one blue. Point character, I'm going to use 2, so a different symbol. I think that's triangles. And then my size is going to be 1. Point size. Okay, Alt-Enter, and there it is. So it adds that to the graph. Okay, now the last thing I need to add here is a legend. So I'm going to use the legend command. 6, 1, this is the XY coordinates of where to put the legend. So I'm going to put it at 6, and then all the way up here at the top at 1. So the should put the legend up here in the upper right. I'm going to label those as plot 1, plot 2. I'm going to use those same colors, red and blue, line type 1, and my point characters. Okay, let's see what happens. Alt-Enter, and there's my legend. Right, so I've got my blue and red lines, plot 1, plot 2. Great. So now you can save this plot. You can export it. You can copy it to the clipboard and paste it in your lab. You can save it as a PDF or a JPEG or something like that. Great. The next thing another thing you're going to do in the lab is make a plot, just a simple bar graph with error bars. Now, there's easier ways to do this in R with different packages and stuff, but we're going to keep it real basic using the basic R commands. So for this one, you're going to use the Lepidoptera, the New Hampshire Lepidoptera data. And this is basically data from two different locations in Hubbard Brook Experimental Forest and White Mountains National Forest, and there's several plots in each one. So let's just read it in. Again, it's a tab delimited text file. Enter. So we've read that in, and so we can see 74 observations of 3 variables. Let's look at it over here. nh.lepid. So this is Lepidoptera larvae, so like caterpillars, that they collected in these 74 plots, and they measured the average biomass of those caterpillars in those plots, right? So HB, Hubbard Brook biomass, and White Mountains biomass, and there it is in milligrams going down. Okay, great. So let's say we want to compare the mean of those two locations and make a bar graph with standard errors and so on. So here's what we're going to do. One thing you can do to compare means is you can just do a t-test, right? So here you can use this t-test function, t-test, and then this is just what two variables are you going to compare, and so NH-lepid is the variable I created, $, HB biomass, and then the other one, WM biomass. So let's do that, Alt-Enter, and here's the results of your t-test down here, right? So it gives you your t-statistic, your degrees of freedom, your p-value. Notice the p-value is very high. That's indicating there's probably not a big difference between these means, right? And it also gives you the mean of the two columns, right? So 3.5 to 3.75, right? So not a big difference. But if we want to make a graph, here's how we can do it. So first we need to calculate the means, standard deviation, and standard error. I'll leave it to you to figure out which one of those you should use for your error bars. Should you use standard deviation or standard error? The example I'm going to give you here is standard error. Okay, so I'm going to create a variable called site, and I'm just going to label those HB and WM for Hubbard Brook and White Mountains. Send that over. I'm going to calculate the mean, so you can just use the mean function, mean of each of those two columns. Enter. I'm going to calculate the standard deviation. That's just this SD function of this column and SD of that column. Enter. And then we're going to calculate standard error. So remember, standard error is the standard deviation over the square root of the sample size. So what I'm saying here is standard deviation of the NH lepidopteran HB biomass, so the Hubbard Brook biomass, divided by the square root of the length of that column. So the length of the vector basically is the sample size, right? The number of entries in there. So I'm going to do that for HB, and then if you look over here, I do the same thing for WM. Okay, let's run that. Alt-Enter. And then we're going to combine all of those that we just made into one data frame. So I'm going to call it Lepid Summary, and it's going to be a data frame of all those things I just created. Site, mean biomass, standard deviation of biomass, and standard error of biomass. Alt-Enter. And then if I type down here, Lepid Summary, there it is, right? So my site, HB and WM, mean, standard deviation, standard error, right? Simple. Now to make a bar graph, I'm going to create a new variable called myPlot, and I'm going to use the bar plot function, and I'm going to tell it plot the mean biomass. So I'm going to use this column in the data frame down there. The names I'm going to put names on the categories, so Hubbard Brook and White Mountain. The Y limit is going to go 0 to 5 because my mean is about 3.5, 3.75 plus a standard error of about 1, so 5 should be high enough on that Y axis. My Y label is going to be mean biomass, milligrams. My main title, Lepidoptera larvae biomass. Okay, let's run that. And there we go. Very simple bar chart, right? Here's the means, Hubbard Brook and White Mountain. Now we want to add error bars. So I'm going to use SE, standard error, for error bars. So I'm going to use this arrows function. So arrows, and that means just, you're drawing an arrow on the graph, but I'm going to draw these sort of flat top arrows. So my plot, so that's the plot that we made before. And then the arrows are going to be the mean biomass minus SE, and my plot Lepidoptery summary plus standard error. Right? Code, that's just going to be the type of line, and angle means 90 degrees. I'm going to have a flat topped arrow. Let's run that. And there they are. Right? So, very simple. That's again, you can export that for your lab. So you're going to make these plots, plus you'll do similar things with some other kinds of data. That Tennessee moth data is another example that you'll use. Okay, so have fun doing this week's lab, and let me know if you have questions.